Welcome. This is Vectors Part 2. Where in this lesson we're going to add vectors graphically. Okay, to add vectors graphically, it simply means that we're going to find the resultant vector. And the resultant vector will represent the sum of the vectors that we're adding together. To add vectors that are in the same direction, we simply add the magnitudes and keep the direction. For example, if I had this blue 20-meter vector pointing to the east and I want to add to it 10 meters to the east, I simply add the two magnitudes, which is 30 meters, and keep the direction, so the resultant would represent a vector that's 30 meters east. Very simple. Hardly worth doing graphically because they're exactly in the same directions. Doesn't matter the direction, could be 45 degrees or 10 degrees or anything like that, as long as they're in the same direction. Now, to add vectors that are in the opposite direction, where instead of adding, we're going to subtract the magnitudes and keep the direction of the, quote, biggest. Let me tell you what that means. Let me show you. If we had that same 20-meter vector going to the east, and now we're going to add to it a 10-meter that's pointing to the west, then we actually subtract the two, and we would end up with this little vector that's 10 meters pointing to the east. So it's like we're just taking the 10 away from the 20-meter. Okay, so those two methods are very easy. And again, the graphics method not really help a whole lot. The next one is, what do we do if we have vectors that are not in the same or in the opposite direction? Okay, so this is called the tail-to-head method that we use. And it's done by, it's referred to as the graphical method. So sometimes it'll say, add these two vectors graphically. And so that's what it means. You're using this tail-to-head. So in brief, we basically take the tail of B, that's the end without the arrowhead, the tail of B, and put it on the head of A. So A is drawn to scale, B is drawn to scale, and then the resultant goes from the open tail to the open head. You can see how the purple one is drawn in there. So that represents the vector R represents the sum of the two vectors A and B. And then to find the value of the result, and then we measure. Okay, so I've got some steps that I'm going to go through to show you how to do that, and then we'll do some examples. Okay, so the tail-to-head method works basically like this. We draw the first vector to scale. We then draw the next vector using exactly the same scale, but we place it on the end of the last vector. So in this case, we would have drawn A first to a particular scale, like you learned how to in the first lesson. And then instead of drawing B down here or out some other place, we put it right on the end of A using the same scale. The next step is step 3. We repeat that. So if we happen to have 3 or 4 or 5 vectors we're adding together, we just keep putting the next vector on the end of the previous vector. Then when we're done, we draw the resultant vector R. And it goes from the open tail to the open head. You'll see how that works when we get to the example. We then use the same scale to measure the value of the magnitude with the ruler, and then we measure the angle with a protractor from a convenient reference. Okay, so let's do an example. Here's our first example. 190 meters, 30 degrees north of west. We're going to add to it 230 meters, 15 degrees east of south. Okay, so we're going to take the first one. So to draw 190 degrees, 30 degrees north of west, we're going to, we first need to have a reference, right? So I'm just going to put this west line right in the middle here. Maybe I have to move it down a little bit like that someplace convenient on your paper. I am then going to figure out a scale to use. So I look that I have 190 and I have 230. So the scale I chose to use is 1 centimeter equals 10 meters. Okay, to do that, the first one, I will take the 190, I'll divide it by 10. It gives me a 19 centimeter vector. Okay, so if you remember from the steps that we did for drawing vectors, let me see if I click on that. We are going to, we have to draw a reference line. So we've already calculated the length of the vector, and then we did the reference line. Now we're going to measure the angle. So I go to, I get my protractor out, and I need 30 degrees north of west. So I put the west line in as my reference because that's what it's referencing, and I'm going to go up or towards the north 30 degrees. So I use my protractor, put it on the end of my reference line, and then I make a tick mark at 30 degrees, someplace out there, right? And then my next step for that was to now measure that from the end of the line. So I remember that I'm starting from the end there. I then take my ruler, and I need 19 centimeters. So I'm going to line that up with the tick mark. Whoops. I'm going to line that up with the tick mark, and I'm going to put 19 right on the end of that and right through my tick mark, and then I'm going to draw my vector, which I have conveniently drawn ahead of time. So you don't have to watch me do that. That looks like it's a little long. Let's see if that's about 19. You have to give me a little bit of leeway here because I'm doing it on the computer, but you'll draw it very accurately. Okay, done with my ruler. Okay, so now I'm going to label that. So that's the vector that I have just drawn right there, and then I'm going to measure my 30-degree angle, put that right in there. Okay, so I've drawn that, and that was the first steps that we learned in the last video. Okay, so now I'm going to take the next one, the 230 meters at 15 degrees east of south, and I'm going to draw that. So my reference line is, of course, the south line. So I'm going to put that reference on the end of my last vector. So now I'm going to measure my angle from that reference because I want to put it right here. It's a 15-degree angle. So I take my protractor and I'm going to put it on the end, put it on the end of that reference very carefully. Measure that with accuracy. Excuse me. Marking a 15-degree angle. So here's my 90. I can just go back 15 on that, put a little tick mark. Protractor's done. And then I draw my, I need to have my ruler next, right? You guys all know how to do this because you did it in the last lesson. So then I'm going to measure this out. I forgot to calculate my length. So let me do this calculation. So I take the 230 divided by my scale. Remember to use the same scale or else it's not going to work. So now I need a 23 centimeter. And so I draw that out that way and I have that one. Let me adjust things so I can show you what's going on. That's okay. So I have 190. I have the 230 that goes out that direction. And then I can even label my 15-degree angle right there. Okay, so now I've drawn my two vectors to scale. And then remember when I'm going to draw my my resultant, I go from the open tail to the open head. And so I'm going to draw that very carefully with a straight edge. Let's see if I can put that right on the end of there. So that represents my resultant. And then to get the value of that, I use my ruler. So I'm going to measure the length of that. And then I'm going to adjust it to the scale using exactly the same scale. So I measure that. It came out to 16.5 centimeters. So then I apply the scale, but now backwards because I'm going the other way. So I multiply it by 10. And so it represents 165 meters according to my scale that I use. I then use my protractor, and just so happens that my convenient reference now happens to be that west line right there. And so I'm going to, whoops, flipped it upside down, I didn't need to. So I'm going to use my protractor to measure the angle down there, and I previously measured that. But it just so happens that I already have a reference. You could do the south reference line, but in this case it's going to require you to do a little bit more work. Well, I measure that to be a 50-degree angle, so the resultant R is 106, represents 165 meters at 50 degrees south of the west line. And that's how you add vectors graphically. Hope that makes a lot of sense. Okay, so we're going to do the next example. This next example is 10 meters per second to the north. So that's due north. We're going to add 60 meters per second, 20 degrees north of west. And then we're going to add a third one, 30 meters per second, 15 degrees east of south. Okay, so now I have 3 of them to do. You should go ahead and start working on this. I'm just going to show the pieces as I go. So I'm going to start out doing the first one. That one's in black. So here I have my reference line of north, and it just so happens that this vector goes right along the north line. So I'm just going to put it right on there. I back up a little bit. I created this scale. I'm using a scale of 1 centimeter equals 2 meters per second. I did that because I had to figure out how I could get it on the page here. So of course your scales, try not to make them too small. If you made it 1 centimeter equals 10, which might work well for the 60 and the 30, but the 10 is going to be so small that it's hardly going to make a difference. So try to make something that's large enough that you're going to get some accuracy. Okay, so I measure, I calculate that first one, and it comes out to, of course, 5 centimeters because I'm dividing it by 2. And so then I measured this out. I don't need my protractor because it's going right along the north line. And so I measure this out to with 5 centimeters going due north. And then I make sure I label it as I do so that I don't lose track of them. Okay, so now the next one is 60 meters per second. So I figure out using the same scale, I'm going to use 60 divided by 2, so I'm going to end up with a 30 centimeter line. That's as long as my ruler that I'm using up here. So I have to make sure, I had to make sure that it fit. There's a little pre-planning. It goes off something like that way. So I had to make sure I planned ahead well. And so first I do a reference line. This one, the reference line is the west because that is going towards the north from the west. So I use a west line. And remember, I put that on the end of my previous vector because that's where I'm going to draw the vector. So I put that right there. Not very easy to get there. And then I use my protractor, and I'm going to measure that to 20 degrees. So I'm going to go up here. By now you should be pretty good at drawing vectors to scale. So it's going to go off that way. So I put a tick mark there. Take that out. Draw my line using my ruler. so I can get the right size at the same time. I'm going to go 30 centimeters, which in this case it doesn't look like 30 centimeters. Take that out, missed it. Oh, it looks like I totally missed, didn't I? So I'm going to draw that out. Extend that out to there. So there's my second one. Be sure you label it. There's that. This is a 20-degree angle, so it goes up from that west line. All right, my next one is a 30 meters per second at 15 degrees east of south. So I start out with my reference line right on the end of my last vector. It's my south line. Right there. I then use my protractor to measure a 15-degree angle. I can do that this way, whichever way I want to use my protractor, and put that on the end there. Whoops, that's not straight. And anyway, you get the point, right? And then measure out with my ruler. I'm now going to go out 15 centimeters. So there's my last calculation. And I use my ruler to do that along my thick line. All right, and then I draw my vector on the end of that. Okay, so now I've drawn all three of my vectors. I then draw a line from the bottom, the open tail, which is the black one, over to the open head, which is the green one, and I end up with something in this vicinity. So I draw all the way from the end. Thank you. Okay, so that represents my resultant. I use the ruler to figure out how long that is. Previously measured on paper, I came up with about a 47 meters per second. And then a convenient line I can use for to measure the angle would be a west line, because it's just almost due west. Ends up to be the way I measure, about 5 degrees south of west. So that just becomes a little bit more complicated than the previous one, where we only had 2 vectors. Now we have 3. There is a chance, depending on the order of that these vectors might overlap each other, and it's okay if that happens. Because if I would have done the black one and then the green one going down that way, and then the blue one, then it may not have crossed over. But it's okay if they cross over each other. There's not a whole lot of accuracy. You have to do the best you can about measuring the length of that, applying the scale to it, so that you get a reasonable answer. In the next lesson, I'll show you how we're going to solve or add vectors analytically, and we'll do that, and we'll get a lot more accuracy from that. Okay, well, let me know if you have any questions. You can comment on this video or send me a note, and I can answer those questions. Okay, thanks for listening.